Hello, and welcome to another IB Math Speedrun with me, Vince. In this video, we're going to be going through in multiple videos, but we're going to be going through chapter 2.4 of the IB Math Analysis HL textbook. So let's jump right in. So chapter 2.4 deals a lot about operations with functions, and just like variables and other elements of math, functions have lots of operations. You can add functions, you can subtract functions, you can multiply functions, divide functions, and there's one special operation that I need to talk about, and it's function composition. And so this involves using one function as the input of another function, because we can do that. I mean, if you've watched, or if you've done any coding, or if you've watched any of my tutorials and you know about functions, this should feel really similar to you. It's like substituting whatever, say, fx is 2x. It's like substituting whatever 2x is in there, but this can have some very interesting results. So, let's talk a bit more about function composition. So, this combines two functions to form a new function, and this can sometimes be written as f circle g x, but I like this form more because it gives you a more clear idea. G circle fx. But for me, I prefer the first form because it gives you a more clear idea of what's going on. It's just personal preference. And so a very common question will be to, given two functions, find the range of a third function made from the two functions. And the domain of this function will be it will be the set that x is an element in G, and x is an element in F. So x is part of the domain of F, and f of x is part of the domain of G. And the range will be a subset of some form of f, and it will be a subset of G actually. And there's multiple methods to find a domain and range, but the most common method I would almost always advise you to use is to calculate the new function made from these two functions. And what do I mean? To really illustrate what I mean, we need to jump into some problems. So today I'm going to be doing the even functions because I'm feeling even today. So the question is 1 for each function. Find, if it exists, gf1 fg2 fgx and gfx. And the first function we'll be doing this for is when f of x is equal to 3x and g of x is equal to the square root of x. Alright, so first let's find g f of 1. So g f of 1 g of f of 1 is going to be equal to g of, what's f1? That's 3 times 1. Substituting that in, which is g of 3, of course. And so this will be the square root of 3, because g of x is the square root of x. Now, for fg2, what's fg2 is equal to f times square root of 2, because that's what g of 2 is equal to. And this is going to be 3 square root 2. So as you can see, Okay, so now let's find fg of x and g f of x. So how would we do this? Well, I'm lagging. Oh, horrible. Okay, well, anyways, f g of x is equal to f times, well, what's a g of x? It's square root of x. And this will be equal to, well, what's f of x? It's 3x, so it would be 3 times the square root of x, because we substituted this into the x here. Okay. Now what's gf of x though? Well, we know that's equal to g, and f of x is 3x, so we'll put 3x in here. And that should be equal to the square root of 3x. So as you can see, the composites of two functions, it really matters which order you put the functions in, and just be aware of that when you're going through questions like these. So, I said we would be doing even, right? But I started an odd, so I guess we'll just do odd. Why not? So the next functions we need to do are hold on. Computer's being a bit slow today. F of x is equal to x plus 1, and g of x is equal to the square root of 2x minus 1. So what's gf of 1? Gf of 1, well, what's f of 1 is 1 plus 1 is 2. That would be g of 2. And that would be square root of 2 times 2 minus 1, which is square root of 4 minus 1 is 3. So it's square root of 3. Now what's g of 2? Well, what's g of 2? We already know that g of 2 is square root of 3. So we can put f times the square root of 3. And f of x is equal to x plus 1. So this will be simply the square root of 3 plus 1. Okay, pretty simple. Now let's move on. So what's f g of x? Well, we know g of x is square root of 2x minus 1, so we need to find what's the f of the square root of 2x minus 1. And that's equal to, well, we just substitute it into this x over here. So we just have square root of 2x minus 1 plus 1. Pretty simple. Now what's g f of x? Well, f of x is x plus 1, so we need to find what g of x plus 1 is. And that will simply be equal to 2 times x plus 1 minus 1, which is equal to, this is equal to 2x plus 1. That's it. Okay, so let's move on to question 3 now. And question 3 is, say f of x is equal to 1 minus 2x. G of x is equal to x squared minus 1. And h of x is equal to the square root of 2x plus 4. And we need to find f. I won't do all of these sub-questions. I'll do the odd ones again. So f h of x and f g h of x. Oh, let's rewrite that. It should be f times g times h of x. So what's f of h of x first? So h of x is x squared minus 1. So, is it square root of 2x plus 4? So we know this is equal to f times the square root of 2x plus 4. And x is 1 minus 2x, so this will be equal to 1 minus 2 times the square root of 2x plus 4. That's it. Now what's f g h of x? Well, this is going to be a bit complicated. Again, this is going to be f of g of root 2x plus 4, which is equal to f of, well, what's g of n? What's a g? G is x squared minus 1, so this will actually be equal to f of square root 2x plus 4 squared, which cancels out, minus 1. which is equal to 2x plus 4 minus 1, 2x plus 3. And since f of x is equal to 1 minus 2x, this is simply equal to 1 minus 2 times 2x plus 3. In other words, it's equal to negative 5 minus 4x. That's it. Okay, let's move on to the next question, question 5. Without using y equals x, find expressions. Such that, okay, so we need to find an expression so that f of g of x is equal to x squared minus 2x plus 3. And to help us out, we know that this will be equal to x minus 1 times, oh, it won't. Oh, interesting. Negative b actually doesn't have roots, so this is interesting, but we can always use something like factoring this into x times x minus 2 plus 3, and then taking a function from this. So in this case, if g of x is equal to x minus 2, and f of x is equal to x plus 3, oh, but wait, this is squared. So this could cause issues. What would be the best way to do this? I guess we could use something like x times x plus 2 plus 3. So in this case, f of g of x would be equal to f of x minus 2, which is equal to x minus 2 times x minus 2 plus 2 plus 3, which is equal to x times x minus 2 plus 3, which is what we saw earlier. So this is okay. And next we need to find a function. We need to find f of x and g of x, so such that f of g of x is equal to 3 over x minus 2 squared. And I mean, this one can be pretty simple if we wanted it to. It can just be f of x is simply equal to 3 over x, and g of x is equal to x minus 2 squared. And so if we get f of g of x, well, this is equal to f of x minus 2 squared, which is equal to 3 over x minus 2 squared again. Pretty simple. Okay, next question is the final question. So we have a long question. The speed of a car v at any time t hours can be modeled by the function v of t is equal to 40 plus 3t plus t squared. The rate of fuel consumption r at a speed of v is can be modeled as r of v is equal to v over 500 minus 0.1 squared plus 0.2. Find the composite function relating the rate of fuel consumption to the time a trip lasts, and find how long a trip lasted if the rate of fuel consumption was 0.2. Yeah, it was 0.2. If the rate of fuel consumption was 0.2. So of course, sorry, I forgot to mention that V is in kilometers per hour, and R is in liters per kilometer. So, well, what's the composite function? We have V of t is equal to 40 plus 3t plus t squared, and R of V is equal to V over 500 minus 0.1 squared plus 0.2. So this looks like a pretty complex composite function, but we'll find it. So the composite function would be R of V of t, which would be equal to, well, we substitute this into here. So this would be 40 plus 3t plus t squared over 500 minus 0.1 squared plus 0.2. And I think that's enough. I don't think we need to simplify it because it would be very confusing. Yeah. Okay, and so we need to find the length of a trip if the rate of fuel consumption was 0.2. So let's work backwards. 0.2 must have equaled all of this plus t squared over 500 plus 0.1 squared plus 0.2, and we can simply see that these two cancel out. So we have, nope, not in red, we have 400 plus 3t plus t squared over 500 plus 0.1 squared is equal to 0, and so this function on the inside must have also been equal to 0. So 400 plus 3t plus t squared over 500 must have equaled negative 0.1. And so 400 plus 3t plus t squared must have equaled negative 50. Oh, it's 40, not 400. How did that extra 0 get in? Oopsies, sorry about that, but okay, so we have 40, 40t, 40t. So we have 40 plus 3t plus t squared, and in this case, if we subtract 50, this would be t squared plus 3t minus 10 is equal to 0, and so simply it's t plus 5 times t minus 2 is equal to 0, and the time must have been 2 hours. So that's our final answer. So that was all for this speed run. I hope you enjoyed. I hope you are now confident in composite functions, and I hope to see you in the next speed run. See you then.